ever stopped to think about uh, how robots actually learn, and maybe more importantly, how we can learn about them?
It's a great question. And today, we're doing a quick dive into something designed for exactly that.
Right, we've got some material here on the Polytech R3 KC9 Plus educational robotic arm system. Sounds kind of technical.
A little, but the core idea is pretty straightforward. It's
Yeah.
basically a kit. You get parts to assemble a robotic arm.
Okay, an arm. How complex are we talking?
It's got 4 degrees of motion, so it's like 4 controllable joints. Gives you a decent range of movement.
And it has a grabber, I see, for
Yep.
picking things up.
Exactly.
Yeah.
And the whole point is learning how to control that movement and the grabber using a microcontroller.
So it comes as a kit with, well, everything you need.
Yeah, pretty much. You get the controller board, a driver board for the motors,
The servo motors.
the servos, the acrylic parts that make up the actual arm structure, joysticks for control,
Oh, joysticks too. Nice.
and even some sensors, little things to detect light and sound.
Got it. So our goal here is to quickly unpack what makes this specific system a useful learning tool.
Right. Let's maybe start with how you actually, control the thing.
Good idea. Looks like there isn't just one way.
No, and that's quite flexible. There are 4 main methods listed here.
4. Okay, what are they?
Well, you've got the classic wired joysticks, direct, hands-on control.
Simple enough.
Then there's Bluetooth. You can control it using an Android device wirelessly.
Ah, okay, more modern.
Yep. There's also infrared control using another Polytech controller called ARD.icon.
ARD.icon will probably come back to that name.
I think so. And the fourth way is connecting it directly, wired, to that same ARD.icon controller for programming and control.
Okay, lots of options. Now, you mentioned a microcontroller earlier.
The brains, right. What's running the show?
Right, so the system uses the ARD.icon microcontroller, and importantly, it's based on the Arduino open architecture.
Arduino. That's a big name in hobbyist electronics and education, so it's not some proprietary lockdown system. Exactly. That's a key benefit. Skills you learn here are transferable. It has 7 I/O ports, connects via USB.
And compatibility. What computers or devices does it work with?
It mentions Android version 9.0 and up, and also Windows 10.
Okay, so this ARD.icon thing, it's both the controller hardware and software.
It seems that way. Polytech created the ARD.icon software specifically for education.
And how do you program with it? Is it complex code?
Actually, no. That's another big feature. It uses an icon-based block programming environment. Think drag and drop.
Like Scratch or Blockly. Visual programming.
Pretty much, yeah. Makes it really intuitive to get started. Plus, the interface is multilingual. Greek, English, French, Russian are mentioned.
That visual approach is great for beginners, but does it connect to, real code?
It does. And this is quite clever. As you're snapping those blocks together, the software automatically generates the equivalent Arduino code and C code in the background.
Oh, that's smart. So you can actually see how the visual blocks translate into text-based programming. A nice bridge.
Exactly.
Yeah.
It helps demystify coding.
And being open source, does that mean there's support for all the bits and pieces, the sensors and motors?
Yes, it mentions driver libraries are included for the various components, so you don't have to figure out how to talk to the hardware from scratch.
That definitely lowers the barrier to entry. What about testing your code? Do you have to build the whole thing first?
Not necessarily. There's a built-in simulator in the software.
A simulator, so you can run your code virtually.
You can test your program, see how the virtual robot will behave, check for errors, all before you even connect the real hardware.
That sounds incredibly useful. Avoids a lot of potential frustration, I bet.
Definitely. Debugging physical hardware can be tricky. This lets you sort out the logic first.
Okay, so we have the hardware kit, the flexible control, the user-friendly software with simulation. What about actual learning content? Is it just the tools, or is there guidance?
No, there's quite a bit of educational content integrated. It's part of what they call the ARD.icon EB subsystem.
EB educate.
Probably. It's described as having curriculum alignment, self-paced training. The course plans are interactive ebooks.
Ebooks? In what format?
HTML5 and SCORM 2004, so they should work in standard learning platforms like Moodle.
Right. And you mentioned activities.
Yes, specifically 60 STEM activities designed for 5th and 6th grade levels.
60. Wow. What kind of things do they cover?
Well, each activity apparently includes theory, diagrams, the block programming steps, the corresponding code.
And practical exercises.
Yes, and even 30-minute practical video exercises, though it notes those are in Greek.
Okay. But the activities themselves, Any examples?
Sure, things like basic object collection programming, then getting more advanced like motion detection and automatic object selection.
Using the sensors, presumably?
Right. Also, classification of objects based on length, height, brightness with warnings, which sounds interesting.
Definitely using multiple sensors there.
And even adding a memory function to memorize robot postures. Plus, activities focused specifically on joystick and Bluetooth control.
So it builds up complexity quite nicely. It's not just about sending commands, is it? Does the software show you what's happening?
It seems so. It talks about real-time visual feedback, showing which I/O ports are active, graphing signals over time.
Live data.
Yeah, instant measurements, and it even displays the current values of variables you've programmed. Helps you see your code in action.
That real-time feedback loop is crucial for learning. And what about for the teachers using this in a classroom?
There's another component mentioned, the ARD.icon CS subsystem. CS, maybe classroom system.
Could be. What does it do?
It's based on something called Academa CRS, and it's designed as a tool for teachers, creating databases, presentations, exercises, quizzes,
Standard classroom management stuff.
and monitoring student progress, generating reports. Again, noted as being in Greek for this part.
Okay. So wrapping this up, the Polytech R3 KC9 Plus really does seem like a comprehensive package.
It certainly looks that way. It blends the physical building and interaction with pretty accessible software and a lot of structured learning material.
A hands-on approach to robotics and programming, bridging that gap between visual blocks and actual code, with simulation too.
Yeah, hitting a lot of the key points for effective STEM education tools.
It leaves you thinking. With all these control methods, the simulator, the range of activities, what sort of real-world applications or maybe further learning paths could mastering a system like this inspire in a young learner?
That's the really exciting part, isn't it? Where could this foundation lead? It gives a taste of engineering, programming, problem solving.
Definitely food for thought. This has been a fascinating glimpse into this particular educational robotics system.